All right, today we're going to pull back the curtain on the junior math curriculum, specifically for years 7 through 10. We're going to break down what students are learning, why it actually matters, and most importantly, how it all fits together to build this incredible toolkit for solving problems. Let's get right into it.
The classic question, right? Every single student asks this at some point. We've all been there, staring at a page full of equations and just wondering, what's the point? Where's the real-world connection? Well, that's exactly what we're here to find out. And trust me, the answers are often way more surprising and useful than you'd think.
So first things first, let's reframe how we think about math. It's not just a bunch of abstract problems on a page. Think of it more like a language, or even better, a universal blueprint that helps us describe and build the world around us. From something as simple as a sale at a store to a massive bridge, math is the how-to guide for pretty much everything.
So in this first part, we're going to lean into that very idea, math as a blueprint. We're going to see how all those concepts taught in school are actually designed to create a powerful framework for solving real problems out in the real world.
You know, the best way to imagine this whole journey from year 7 to year 10 is to think of it like building a toolkit. Seriously, every year, students are adding new, more powerful tools to their kit, and they're learning how to combine them to tackle bigger and bigger challenges. It's all about building capability, one tool at a time.
So let's start at the beginning, with years 7 and 8. This is where the foundational tools are made, the absolute essentials that everything else gets built on. These are kind of like the hammers, the screwdrivers, and the wrenches of the math world. You gotta have them.
One of the very first tools that goes into the kit is percentages. This pops up in year 7, and it's really just a simple, standard way to talk about parts of a whole. It's a tool for comparison, making it super easy to understand proportions just by looking at them.
And you use this tool everywhere. I mean, just look at how practical these examples are. Figuring out that 20% off sale, understanding the tax on something you buy, even adjusting a recipe in the kitchen or checking your bank statement, percentages are a tool you will absolutely use probably every single day.
Then, in year 8, we get a more specialized tool, the famous Pythagoras theorem. It gives us this really precise relationship between the sides of any right-angled triangle. And that little formula, you know the one, a squared plus b squared equals c squared, it is incredibly powerful.
So what does this tool actually build? Well, some huge things. It's fundamental to how your GPS finds the shortest route. It's used in construction all the time to make sure corners are perfectly square and stable. It just goes to show how a simple rule about triangles becomes the backbone of modern tech.
And you can really see this year-on-year progression with something like probability. In year 7, students learn the basics, like what's the chance of rolling a 6 on a single die. But by year 8, they're leveling up and combining events, like calculating the odds of rolling 2 dice to get a certain number. The complexity just builds step by step.
Okay, so now we're moving into the big leagues, years 9 and 10. The foundational tools are all there in the toolkit, so now it's time to add the power tools. This is where students really learn to combine their skills to build complex models of the world.
This right here is a perfect example of that progression. You start with percentages way back in year 7, then you add linear equations in year 8. In year 9, you combine them for financial math to figure out interest, and bam! By year 10, you're using exponential functions to model complex investments. See how each step builds directly on the one before it?
Another one of these power tools added in year 9 is trigonometry. Now this takes what we know about triangles to a whole new level. Using sine, cosine, and tangent, we can suddenly figure out unknown angles and distances without ever having to measure them directly. It's kind of like a superpower.
And its applications are just massive. Trigonometry is absolutely essential for surveyors mapping out land, for pilots navigating through the sky, and for engineers designing huge structures like bridges. It's the tool we use to measure and build our world on a truly grand scale.
You know, this slide does a great job of showing how a core skill like algebra evolves. In years 7 and 8, it's all about the basics, simplifying expressions, solving simple equations. But by years 9 and 10, that solid foundation lets students tackle much more complex problems, like analyzing the parabolic arc of a thrown ball. All right, so we've forged the essential tools, and we've added the power tools. The toolkit is looking pretty complete. In this final section, let's look at the payoff, what you can actually build and solve with this amazing mathematical toolkit you've put together.
At the end of the day, this 4-year journey is about so much more than just passing tests. It's building the foundation for senior math, sure, but it also opens doors to some of the most in-demand careers out there. In tech, finance, engineering, data science, these are literally the fields that are building our future.
And here you can see the core of that toolkit. These are some of the most essential formulas learned along the way. Think of this as your starter kit. Each and every formula on this list unlocks a different way to measure, model, and make sense of the world.
So there you have it. Math isn't just some subject you have to get through in school, it's a blueprint for problem solving. You've now seen how the toolkit gets built, piece by piece, from simple ideas into really powerful applications. The only question left is, what are you going to build with it? What problem will you solve first?